In trigonometry, there are angles that are called special angles. Okay, these are angles in which have maybe zodiacal expressions and the rest. But then we'll be looking at these angles, we'll find the specialty in them. Is it something that can be recalled easily? So let's take a look at it. We are talking about angles like 45 degrees, angles like 30 degrees, 60 degrees. We are looking at 0 degrees, 90 degrees, 180 degrees, and likewise 360 degrees. So most of these angles have answers. If you take the sine, cosine, and tangent of them, they can be 0, 1, 1 over 2, root 3 over 2, which are easy to remember. So let's begin with 45 degrees. 45 degrees. Now, for us to be able to obtain these trigonometric identities without using trigonometric tables or using any, maybe calculating or anything, these are called special angles because we can evaluate these angles without using calculators or even the trigonometric tables. So now, 45 degrees, let's take an isosceles triangle we want to derive. Okay, it's very simple. Let's take a right angle triangle or an isosceles triangle. Let's use the right angle triangle in which the opposite is equals to hypotenuse, which represents 1. So we have opposite is 1, the hypotenuse is 1. Now if this angle is equals to 45 degrees, definitely this angle is also equals to what? 45 degrees, because like we said in the last video, these two angles are complementary. All right, let's erase that part. So 45 degrees and 90 degrees all will sum up to give us 180 degrees, which is the sum of angles in the right angle triangle. So the opposite is equals to the adjacent, which is equals to 1. The question, what is the hypotenuse? If we recall back to our lesson on Pythagoras theorem, where we're dealing with right angle triangle, we'll see that hypotenuse squared is equals to opposite squared plus the adjacent squared. This is called the Pythagoras theorem. So let's evaluate the hypotenuse. Hypotenuse is equals to 1 squared plus 1 squared, which is 1 plus 1, which is equals to 2. So therefore the hypotenuse squared is equals to 2, and we can find an answer for the hypotenuse, which is root 2. So if this is root 2, now with this we can duplicate this and we deal with it there. We will now find an expression for sine 45 degrees. We will find an expression for cos 45 degrees and also an expression for tan 45 degrees. Remember, we are using the principle of SOHCAHTOA, where sine is equals to opposite over hypotenuse, cos is equals to adjacent over hypotenuse, and tan is equals to opposite over adjacent. So with this, let's dive in. I want to express sine 45 degrees. Let's consider this angle 45 degrees. This will be the opposite and this will be the adjacent, and this is the hypotenuse. And even if we consider this angle 45 degrees, the opposite and the adjacent will still be same. So the opposite of sine 45, considering sine 45, the opposite is 1, the hypotenuse is root 2. Cos 45 degrees says that the adjacent over hypotenuse, the adjacent is 1, the hypotenuse is root 2. Similarly, tan 45, as the opposite of 1, the adjacent is 1, which is also equals to 1. Now with that, we can say, applying the rule of sorts here, that sine 45 degrees will be equals to 1 over root 2. And in short, we don't like in mathematics, we hate the fact that when we have solidical expressions at the denominator, so we have to multiply the numerator and the denominator by the expression in the denominator. So this will give us root 2 over 2. For more understanding on this, kindly refer to our lesson video on surds. We dealt with rationalizing the denominator. So now we have sine 45 degrees is equals to root 2 over 2. In the same vein, if you multiply the numerator and denominator for cos 45 degrees, that's multiplied by root 2 divided by root 2, and cos 45 degrees will also be equals to root 2 over 2. And finally, our tan 45 degrees is also equals to 1. Now, if we use our calculator, maybe a scientific calculator or just a normal calculator to express this, we have that sine 45 degrees is equals to root 2 over 2, which is similar to 0.7071, 0.7071, and our tan 45 degrees is equals to 1. So now we have been able to evaluate the expression for sine 45 degrees, the expression for cos 45 degrees, and also tan 45 degrees. Let's move to the next one. 30 degrees and 60 degrees. We can derive them together. So we have 30 degrees and let's go and 60 degrees together. Now, to find the expression of sine 30 degrees, cos 30 degrees, and tan 30 degrees, and likewise sine 60 degrees, cos 60 degrees, and tan 60 degrees, we will be using an equilateral triangle. An equilateral triangle of sides 2 units. So we have a triangle, equilateral triangle, whose length is 2 units. 2, 2, and 2. Now, if it's a equilateral triangle, definitely the sides, the angles are equal, which are 60 degrees. 60 degrees and 60 degrees. So with this, let's label the triangle. Let's call this A, B, and C. Now we can see 60 degrees is visible on all ends, but when we have a bisector here at point B, a perpendicular bisector, it will divide this angle 60 degrees into 2. So we will have 30 degrees and we also have 30 degrees. It will also divide equally length AC into 2. So this will have 1 and also this will be 1. So I can say that the total length is 2. And we can we can call the point of bisection to be D, and it is right angle because it is perpendicular triangle. Now we have the same angle on the left, the same triangle on the left to be the same triangle on the right. We have this to be on the left. We also have this to be on the right. So with that, we can bring it out for more understanding. Let's bring out the left hand side, or let's say the right hand side rather, and we'll have this. We'll have angle 60 degrees. Okay, we have angle 30 degrees. Is right angled with the hypotenuse of 2 with this side of 1. Call it triangle B DC. BDC. This is 60 degrees. So with this now, we can now express the values of sine theta, sine 30 degrees, cos 30 degrees, and tan 30 degrees, and likewise sine 60 degrees, cos 60 degrees, and tan 60 degrees. So let's move on to the next page for more understanding. we have 60 degrees, we have 30 degrees, 2, 1, and it is right angled. Now, how do we go about this? We have a missing length. Let's call this missing length B, or let's say X. Let's apply Pythagoras theorem in this case. Pythagoras theorem says we have hypotenuse squared is equals to the opposite squared plus the adjacent squared. That's the hypotenuse squared of a right angle triangle is the sum of the individual squares of the other two sides. So with that done, we can say that 2 squared is equals to, let's call the opposite x and the adjacent 1. Opposite x, adjacent 1. Therefore, this will give us 4 is equals to x squared plus 1, making x squared the formula. So therefore, we have x squared is equals to 4 minus 1, which is equals to 3. Therefore, x squared is equals to 3, and x will be the root of 3. Now we have an expression for x, which is the root of 3. X now is equals to 3, root 3. Now with this, we can duplicate what we have here and then find an expression for sine 30 degrees, cos 30 degrees, and tan 30 degrees, and likewise the same for tan 60 degrees, cos 60 degrees, and sine 60 degrees. So let's begin with 30 degrees. 30 degrees, we want to evaluate for tan 30 degrees, we want to evaluate for cos 30 degrees, we also want to evaluate for tan 30 degrees. So with that, let's proceed and apply SOHCAHTOA. Sine, as we know, is opposite. Okay, we are applying SOHCAHTOA. Let's have it here. Sine, as we know, is opposite over hypotenuse. The opposite in this case, this is 30 degrees. So 1 is the opposite, okay, and root 3 is the adjacent. So with that, we have the opposite of sine 30 degrees. Opposite is 1, the hypotenuse is 2. So sine 30 degrees is 1 over 2. If we move on to cos 30 degrees, we know that cos is equals to adjacent divided by hypotenuse. So we understand that cos 30 degrees is equal to root 3, which is the adjacent, divided by the hypotenuse, which is 2. Now you observe that there is no need for us to rationalize here because there is no solid expression at the denominator. Similarly, let's evaluate tan 30 degrees. Tan is equals to opposite over adjacent. The opposite now of tan 30 degrees, opposite is 1, the adjacent is root 3. Now there's a need for us to rationalize the denominator because there is a solid expression at the denominator. So we multiply the numerator and denominator by the denominator. Remember to take a look at surds, okay, which is what we dealt on rationalizing the denominator. So simplifying this, we'll have that our tan 30 degrees is equals to root 3 divided by 3. Now with this done, we can take the decimal relation of this. So this will give us 0.5. 1 over 2 will give us 0.5. That's sine 30 degrees. Cos 30 degrees, using our calculator, will give us 0.8660. And tan 30 degrees will simply give us 0.5774. This is for 30 degrees. So we arrived at sine 30 degrees equals to 1 over 2, cos 30 degrees is equals to root 3 over 2, and tan 30 degrees is equals to root 3 over 3. Now let's move on to 60 degrees. Remember, all we just have to do is to duplicate this triangle with the dimensions. Let's duplicate and we'll be dealing with this. Will change to root 3. We want to deal now with 60 degrees. Will have root 3 to be the opposite, and 1 to be the adjacent, and 2 to be the hypotenuse. So now let's begin. We want to evaluate sine 60 degrees, cos 60 degrees, and tan 60 degrees. Remember, we are still applying SOHCAHTOA. So we understand that sine is equals to opposites over hypotenuse. So this will mean our opposite is root 3. So this will have sine 60 degrees is equals to root 3 divided by 2. Okay, and moving on, we want to evaluate cos. We understand that cosine is equals to adjacent over hypotenuse. So therefore our cos 60 degrees will be equals to the adjacent, which is 1, and the hypotenuse is 2. And we do the same thing for tan 60 degrees. Tan 60, tan in its own general expression is opposite over adjacent. The opposite in this case is root 3, and the adjacent is 1. So we are saying that tan 60 degrees is equals to root 3. Now, the decimal representation of each, we'll say this is equals to 0.8660, cos 60 degrees is equals to 0.5, and tan 60 degrees is equals to root 3. Root 3 is in our calculator, will give us 1.7321. So now we have arrived for sine 60 degrees, cos 60 degrees, and also tan 60 degrees. Now what is left? We are left with we have done 45 degrees, done 60 degrees, done 30 degrees, done 60 degrees, and we are now left with 0 degrees, 90 degrees, and 180 degrees with 360 degrees. So let's do that in the next lesson video.